This conference will now be recorded.
So what is a data structure basically? If anyone of you know about C language, I think you people listen the term data structures in C language, right? If you are aware, in C language, we have data structure algorithms like linked list, single linked list, double linked list, circular linked list, stacks, queues, trees, binary trees, graphs, these all. But actually, you need to write hundreds of lines of code to implement data structures in C language. Because originally in C language, you don't have data structures. You don't have built-in data structures. Using the C language, you are creating your own data structure over there. Nothing is readily available in C language. But in Python, we have readily available inbuilt data structures. First of all, what is the data structure? Structure of data, format of data, to store and organize the data effectively, right? So data structure is a way, is a mechanism, it's a systematic way of store and organize data in the memory. Okay, what is data structure? It is a systematic way of store and organize data in the memory, right? So that whenever you store and organize the data systematically, adding the saving the data, reading the data, searching for data, okay, these all operations, all the data operations become easy and faster. That's the reason we go with data structures. There are multiple data structures, different data structures are available. Python has built-in data structures, readily available structures are there. There are multiple data structures. Each data structure is meant for the suitability of a particular purpose. Each data structure has its own purpose to suit a particular purpose. So Python is having data structures like list, tuple, set, dictionary. These are the data structures we have. Okay. List, tuple, set, dictionary. Of course, apart from this, we have collection objects also, ordered dictionary, default dictionary, those things. But no one uses it because ordered dictionary, default dictionary is just extension of the dictionary only. Already those features are nowadays given in the dictionary, so need not worry about it. And the DQ, heap queue, these kind of collection objects are there. Deep queue, heap queue is just extension of the list only, nothing special. That's why even you ignore those collection objects, not a problem. But data structures such as list, tuple, set, dictionary, these things are, these four data structures are very important. So list in the Python is similar to linked list in C language. Only the difference is in C language, you supposed to create your own links, your own list. You supposed to construct with the pointers and structures concept. Here you need not to do that. List is readily available. A dynamic array. List is collection of items. List is collection of items. An item can be any Python object. List is collection of items. An item can be any Python object. An item can be any Python object. So it can be, an item can be an integer or string or boolean or complex, anything. It can be a list. It can be a tuple. It can be a set. Even in Python, as I told you, function is also an object, class is also an object. Those all are Python objects only. So an item can be any Python object. List is collection of items. An item can be any Python object. List supports indexing. List supports indexing. It supports positive index and negative index both. Positive index starts from 0, negative index starts from -1. The same like string. It supports indexing, positive index and negative index both. Positive index starts from 0, negative index starts from -1. List is mutable. List is mutable, allow changing its content. List is mutable, it allow changing its content. List allows duplicates. List allows duplicates. List allows duplicates. List is unhashable. List is unhashable. Okay, this is basically what is list. Tuple is almost like a list. Tuple is collection of items. Tuple is collection of items. An item can be any Python object. Tuple is collection of items. An item can be any Python object. See here, list enclosed within square brackets. It is collection of items. This is list if you want to make a list. Similarly, tuple. Tuple is similar to list only. The difference is enclosed within a parenthesis. It is collection of items. An item can be any Python object. Okay. Tuple supports indexing, positive index and negative index. Positive indexes start from 0, negative indexes starts from -1. Okay. Tuple allows duplicates. Tuple allows duplicates. Tuple is immutable. Tuple is immutable. Does not allow changing its content. Tuple is hashable. So majorly what is difference between list and tuple? List is mutable, tuple is immutable. List is unhashable, tuple is hashable. Simply to say, list and tuple almost the same. Tuple is a read-only list. Tuple is nothing but read-only list. Okay. Yeah. Next, one more is a set. One more is a set. Set enclosed within curly brackets. Set enclosed within curly brackets. Okay. Set is a collection of items. Set is collection of items. An item can be any hashable Python object. An item can be any hashable Python object. So all fundamental type objects are hashable. All fundamental type objects are hashable. And tuple is hashable. So set allows only hashable Python objects. It doesn't support indexing. There is no matter of indexing. Order of placement of items, no guarantee. Order of placement of items, no guarantee. Its own order, it follows its own order. It doesn't follow the order of values which we provided. Okay. And set is unhashable. Set is mutable. Set is unhashable. Set is mutable. It does not allow duplicates. It does not allow duplicates. So the main purpose of this set is mathematical sets, to operate mathematical sets, union, intersection, difference. These all mathematical set operations are there. For that, we use sets. That is set. The purpose of this set is mathematical sets. Simply to speak about set, set is unordered collection of unique set of items. Set is unordered collection of unique set of items. This is what set. Okay. Next, what is the dictionary? Dictionary is a collection of key value pairs. Dictionary is collection of key value pairs. Actually, type is dict. Class name is dict. A dictionary is enclosed within curly brackets. Then key colon value, comma. Key colon value, comma. This is one item in the dictionary, right? Before colon is the key, after colon is the value. What is key? Customized index itself is the key, right? So there is no default indexing. Index starts from 0, index starts from -1. Know those all things. Okay. Here the key itself is the index. But who is giving the key? We are giving the key. That is the customized index, right? Then value is value. Please understand in that way. So like this collection of key value pairs. Like this collection of key value pairs. That is dictionary. That is dictionary, right? This is what list, tuple, set, dictionary. Very simple. Dictionary is mutable. Adding items, deleting items possible. Okay, values can be duplicated, but key should not be duplicated. Values can be duplicated, but key should not be duplicated. Okay, value can be any Python object. Key must be hashable Python object. Only hashable Python objects are allowed as a key. This is just what is what. Let us see simply. You observe. Parallelly, we observe list, tuple, and also set. Let us observe. See how to make a list. This is the list. This is the list, right? Okay. So list with all simple numbers. List with all simple numbers. So enclosed within a square brackets. Otherwise, using list function, you can convert any object into list. Tuple you want to convert into list. Set you want to convert into list. You can use list function. Okay, list function returns the list object that is used to convert into list. Using this list function also we can create a list. Class is list. List is Python object. It occupies its own memory, right? So list with all string values, making list with all string values. Here square brackets. Here is the list conversion function. Okay. This is how you can create a list. You can create a list with the different varieties of items, because an item can be any Python object, right? An item can be any Python object. This is the empty list. This is list object only, but no items in the list object. That is the empty list. Okay, list object only, but no items in the list. So empty list. This is a single item list. This list is having only one item. Single number is different. An item in the list is different, right? Single number is different. An item in the list is different. Antena? Individual house, single flat apartment. Kani single flat apartment is different kada. Adi individual house kaadu. Got it? Of course, you can have multiple flats also in that. So here list is list, but in the list you have only one item. List is list object. In that list you have one item. That is single item list. A simple number is integer object. It's not going to be a list object, right? Single string is a string object. It's not going to be a list object. Single float value going to be the float object. It's not going to be list object. This is single item list. List allows duplicates. Duplicates are allowed or not? Understand? This is simply how to make a list. List with all simple numbers, list with all string values. So homogeneous values are allowed. List with different varieties of values. The values can be anything, heterogeneous. An item can be any Python object. Okay. Next, empty list, single item list. List allows duplicates. Similarly, if you observe tuple, same, only the difference is parentheses. I'll show you one magic. Even though you are not giving a parentheses, then it makes tuple only. See, I'm opening ideally. In the first chapter, variables, I told you, assigning a single value to the multiple variables, that you understand. Assigning multiple values to the multiple variables, I told you, that you understand. Assigning multiple values to the single variable, right? This also make tuple. What type of object it is? Tuple. Understand? Even though you are not giving parenthesis, it gives tuple. But please observe single item tuple. Single item tuple. So some B is equal to, within the parenthesis I am giving 45. This is not going to be single item tuple, this is going to be simple integer. Understand? Even though you kept in the parenthesis, it's not going to be single item tuple, it's going to be integer. Right? Understand? Then how can I make single item tuple? Put a comma, something y is equal to parenthesis 45 comma, right? End with the comma. Then y is going to be single item tuple, right? It's going to be single item tuple. Otherwise x is equal to something 65 comma. I did not use parenthesis, but end with the comma. So then x is going to be single item tuple or not? Got it? This is also a way of making tuple. So by default, if you do something, automatically Python considers take it as a tuple. So if you want to create tuple with all simple numbers, understand? Tuple with all simple numbers. So tuple is the conversion function to convert into tuple. Here actually this is the list. List has been converted into tuple using tuple function. Tuple is created, right? So this is a way of creating tuple. Tuple is the conversion function to create a tuple. So tuple with all simple numbers. Similarly, tuple with all string values, because tuple and list are almost the same. Only the difference is tuple is read only. Tuple is immutable. Tuple is hashable. That's only the difference. Now you see tuple with the different varieties of items, heterogeneous. Empty tuple, okay. Single item tuple should end with a comma. Otherwise, single item list I am converting into tuple, so it becomes a single item tuple. Single item tuple definitely ends with a comma. Tuple allows duplicates. Tuple allows duplicates, right? This is how making a tuple. Clear? How to make tuple? Then similarly, you observe list set. Please observe carefully. Enclosed within curly brackets is the set. Observe what are the order of the values I have given. I provided the order of the values. Using the set conversion function also we can create a set. Actually this is a list I am converting into set. Using set conversion function also we can create a set. Please observe. This is the what set it's created. See, this is the order of the values I have given. This is the order of the values system has taken. అర్థమైందా? నేను ఇచ్చిన ఆర్డర్లోనే అది తీసుకోదు. నేను ఇస్తా, ఇచ్చింది తీసుకుంటది, దాని ఇష్టం వచ్చిన ఆర్డర్లో అది పెట్టుకుంటది. అర్థమైందా? గిఫ్ట్ ఇయటం నీ వంతు, అది హాల్లో పెట్టుకోవాలా బెడ్రూమ్ లో పెట్టుకోవాలా తీసుకున్న డిసైడ్ చేసుకుంటారు. అంతే కదా? Similarly, so order of the items no guarantee. It is an unordered collection of items, right? It is an unordered collection of items. See here, set with all the strings. See, order of the items which I provided, order of the items which it has taken. Different varieties of items. Set with the different varieties of items. Empty set. Please be careful. This is not going to be empty set. This is going to be empty dictionary, because the set enclosed within the curly brackets, dictionary also enclosed within curly brackets. In between the curly brackets, it is just a series of items. It's going to be set. It is series of key value pairs. It's going to be dictionary. Empty curly brackets, automatically take it as a empty dictionary. Correct. If you want to create an empty set, definitely using a set function only, you can create empty set. This is empty set. Set with a single item. Okay, fine. Set with the duplicates. Will it allow duplicates? No. Set does not allow duplicates, right? That is a proof. So what is the order of the items arrangement? Is it ascending order or descending order or something? No. You look at this example. Is it ascending order or descending order anything? No. Its own order. Its own order. Set does not support indexing, but it is maintained by, internally it is maintained by arbitrary index generated by the hash function. Internally, set is maintained by arbitrary index generated by hash function. Understand? Clear? Yeah. See, if I give set 1 of 5, set 1 of 8 indexes, it gives an error. Set object not subscriptable. It gives type error, right? Because it does not support indexing. So there is no matter of accessing the element using the index. There is no matter. Got it? This is regarding the set. Next, list. List supports indexing. Tuple supports indexing. Now you observe, just like a memory model of the list, memory model of the tuple, same as a string memory model I was discussed. Now you see, this is the list. My LST1 is a list. These are the elements in the list. This is the list object ID. But individual 0th indexed element, 1 indexed element, 2 indexed element, I am accessing one by one. I am accessing by using positive index. Of course, what type of object it is, what is the ID also I am accessing. See 11, 11, again 11. IDs are same or not? 44, again 44, IDs are same or not? 77, one more 77, IDs are same or not? 88, 88, IDs are same or not? Got it? So memory model is same as string memory model. As well, the same list object you can access in the reverse order by using a reverse index, negative index. This is also possible. So list supports indexing, it supports positive index and negative index. Using those indexes, either positive index or negative index, you can access the individual items from the list. Tuple also the same. This is the tuple. Tuple supports indexing. I am accessing individual items using positive index. I am accessing individual items using negative index. Here also I am accessing, this is the tuple. I am accessing individual items using positive index. I am accessing individual items using negative index. Got it? Fruits is a tuple. Fruits of 9, what happens? Are there 9 elements in the fruits? No. Is the 9 index element available? Not available. So it gives error. List index out of range. Index error. See, my TPL1 of 19, is it having 19 indexes? No. So 19th index element is not available. You are trying to access it, it gives error. The same thing in case of a list also, right? Fruits, same thing I am making as a list, positive index, negative index. So fruits of 9, list does not have such indexed item, list index out of range. Okay, my LST1 17, 17 index is not available, so list index out of range. Almost list and tuple both looks similar, right? Now this is my list. I want to iterate the list using while loop. Using while loop, we can iterate the list and access individual items. See, I is the index. I is the variable I initialized before while. I is less than length of the list. Then inside the while, I am incrementing the I value. Now I value I am using as an index mylst1 of I, type of mylst1 of I, ID of mylst1 of I. I is the index. First time 0, next time 1, next time 2. So 0th index, 1 index, 2 index, it is accessed or not. You can access the list using while loop logic or not. Similarly, reverse index. See, I value -1, I is greater than or equal to -15. Using negative value also, I can apply my while loop logic and access the individual elements or not. Got it? So, list is iterable. Collection object. List is collection object. It is iterable. So, you can iterate the list using for loop. Very simple. For x in for loop variable in list object. List object is iterable. Each and every time one by one value automatically it gets or not. That is the for loop logic. Clear? You can iterate the list using for loop. Similarly, you can access the list. You can access the list using while loop. Sorry, tuple. Tuple using while loop. You can access the tuple using minus negative index. Okay. You can access the for loop using you can access the tuple using for loop. Iterate the tuple using for loop. Got it? Yeah. Set is also iterable. It is a collection object, but it doesn't support indexing. So making use of while loop logic is not possible, but set is iterable. You can iterate the set using for loop. Understand? You can make it as for loop. This is simple understanding about list, simple understanding about tuple. Clear? See, list operations. Please remember, tuple and list both are same. What is the difference? Adding elements, deleting elements, changing elements, not possible with the tuple. It is possible with the list. Okay. See here, 5 indexed element 88 accessed or not. 5 indexed element I am trying to modified or not. But this is not possible with the tuple. This is not possible with the tuple. Okay. See here, len function gives you length of the list. Same length function is possible. You can get length of the tuple. Okay. Append method, add the element at the ending of the list. Add the element at the ending of the list. Okay. So append method is used to add a new item to the list as a last indexed item at ending of the list. 15 is added or not? Insert method at a 3 indexed element, insert the new item. Of course, you have to specify at what index the new item should be inserted. So first parameter is index. Index tells you at what place I should insert. And next second parameter is the value, which value to be inserted. So as a 3 indexed item 75 is inserted or not? Just adding at the ending is the append. Inserting in the middle is the insert. If you want to insert at the middle, you're supposed to specify where to insert. That index value you're supposed to specify. Len function gives you length of the list, len function gives you length of the tuple, it's fine. Then pop method, pop method. Pop method remove an item. By default, pop method remove last item, last indexed item. Pop method remove an item. By default, pop method remove last indexed item. Okay, understand? It returns the removed item. It returns the deleted value, right? It deletes some item. Last indexed item is deleted. What is the item it is deleted? That is returned. You can capture it. You can capture it. See, pop method last indexed item is this one. See, last indexed item is 5 or not, that has been deleted. After deleting that, this is the remaining list. Got it? So that is a pop method. No, sir, I don't want to delete last indexed item. I do specify index of the item which I want to delete. So please give the index. What you have given? Index. 4 indexed item. 0, 1, 2, 3, 4. 4 indexed item is 8. That is deleted. And it returns the deleted item, right? It returns the deleted item. Got it? That is pop method. Pop 9 index is not available, so it gives pop index out of range. This is pop method. Pop method works based on index. It deletes either last indexed item by default, otherwise a specified indexed item. Pop method returns the deleted item. Pop method returns the deleted item. This is a pop method. Next one you see, this is the list. LST4 is the list. Okay, remove method. Remove method search for the given value and delete the value. What is the difference between pop method and remove method? Pop method works based on the index. Remove method works based on the value. Understand? So here you see 99 is deleted or not. Here is the 99. First occurrence of the 99 is deleted or not. So remove method removes only first occurrence of the value, given value. It works based on value. It search for the value and delete the first occurrence of the value. It doesn't return anything. Pop method returns the deleted item because it is working based on index. This itself is working based on value. So doesn't return anything. This is remove method. Okay. Count. Already in the string we observed count. Count of L, count of O, something like that. Count of 11. How many times the 11 occurred? That gets the count. So this is remove method. Already you know. So this is the program to find the biggest number in the given list of numbers. Of course, this biggest number program you can practice on the tuple also. See this remove method, pop method, insert method, okay, append method. These operations, changing the item, these operations are only possible on the list. They are not possible on the tuple. But searching for the values, applying the logic, find the biggest number in the given list of numbers, that is possible on the tuple also, because you are reading the value, you are not doing any changes on the tuple, right? That's why it is possible. Understand? Next, enumerate function. Enumerate function returns the enumerate object. Enumerate object contains collection of tuples. Each tuple contains only two values. One is generated serial number, second one is value from the list. It can be a list or it can be a tuple. See, this is my list, right? Fruits is the list. Enumerate fruits. The parameter to the enumerate function is the list object or tuple object, anything. So these are the values in the list, right? So enumerate function generates serial numbers. Enumerate function generates serial numbers. By default, the serial number generation begins with the 0. So this is the serial number 0. This is the serial number 1. This is the serial number 2. This is the serial number 3. This is the serial number 4. This is the serial number 5. This is serial number 6. The serial number and the item value packed together as a tuple. The serial number and item value packed as a tuple. Serial number and item value packed as a tuple. Like this, all the tuples together is the enumerate object. Understand? Enumerate function makes enumerate object, creates enumerate object. What the enumerate object includes? Generated serial number and individual items packed as a tuple. That collection of tuples are available. Enumerate object is collection object. It is iterable, so you can iterate using for loop. If you print the enumerate object, nothing will be printed. Like this, it will be printed. Object representation is printed. But if you want to iterate, you can iterate the enumerate object using for loop. So see, 0 apple, 1 orange, 2 banana, like this. Index, sorry, serial number and value, serial number and value, serial number and value, right? Are you clear? Yes. So there is a guarantee there will be only two numbers, two values in the tuple. One is generated serial number, second one is value belongs to that object. Value belongs to the list or tuple. Clear? Suppose no sir, I don't want to generate the serial number starting from 0. I want to start my own beginning point. Serial number generation should start from my own specified beginning point. Yes, you can specify where to start with. 25. See, serial numbers are generated starting from 25 or not. It is enumerate object or not. Enumerate object is iterable. So there is a guarantee enumerate object, when you are iterating the enumerate object, each time it gives a tuple. That tuple contains only two values, no change in this, right? It is fixed. So here I am using two iteration variables. So first value goes to first variable, second value goes to second variable. Serial numbers goes to a different variable, value goes to a different variable. Like this, you can iterate the enumerate object. Here I am showing this enumerate in the upon the list, but it is possible on the tuple also, because enumerate object is not really modifying the original list or original tuple. It is making the enumerate object. That enumerate object you are iterating. This can be operated on the list or tuple anywhere. Got it? Understand? Yeah. Now you see the programs, data structures, list programs, enumerate. Then you see I'm able to modify, multiply, assign the value, any kind of logics I'm able to operate it. Okay, see, list 1, list 2, list 1, list 2, there are two lists. List 1 plus number gives the error. List object plus single number, integer object. This plus operation gives error. Multiply number gives repetition. Already I told you in the strings, right? Multiple star operator works as a repetition operator. Same list or tuple, star operator work as a repetition operator. So list 1, both are lists. Plus symbol works as concatenation operator. Got it? Both are concatenated. In between two lists, in between two tuples. This is tuple 1, tuple 2. Plus symbol works as concatenation. So list 1 is not modified, list 2 is not modified. It concatenates and gives the new list object. Understand? Yeah, in operator, not in operator, already we observed in the strings chapter. This is actually a stack program. What is stack? What is queue? First in, first out. What is that? First in, first out. What is that? Stack. First in, last out is the stack. Last in, first out, or first in, last out. Whatever you say, that is the stack. Last in, first out. Otherwise, first in, last out. This is a stack. Something like how you put your books. Book 1, book 2, book 3, book 4, book 5. Which book you can take first? Which one is on the top, right? Last kept one, you can take out first. Got it? That is the stack. Understand? What is queue? Cinema hall queue, hospital queue, bank queue. We have several queues. First come, first serve. That's all. లేదు సార్ మేము నెట్టి నించుంటాం సార్ ఇంకా మీ ఇష్టం. Okay, see here what I am doing. One append will add the item at the ending. Append will always add the item at ending. So first item, second item, third item, fourth item I added. Empty list. Each time I append, one item will be added at the ending. Then pop 0 deletes the 0th indexed item. Whenever I delete, it deletes the 0th indexed item. 1, delete the 0. Second, delete the 0. So first in, first out, right? This is the queue. In case I doesn't give 0, what happens? Last in, first out. Last in, first out. This become as stack. See, very simple. We can do this program in Python. Just to not more than 25 lines, including the menu print commands. Okay, but same stack program, if you implement in C language, it is more than 300 lines, 300-400 lines of code you're supposed to write. Because the structure also you are building, your structure is readily available, behavior is readily available, just using the existing structure called list. Got it? Yeah. Like this, anything you can do. Append method, a list appended into another list. So a list is added, right? See, fourth index item, fifth index item is list. Understand? Integer, 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 list. Got it? List is Python object. A list is possible inside the list. A list is appended to the list. Got it? This is append method. Insert method. So at the to index, list is inserted. To indexed item is a list or not? Okay, list inside the list is allowed because list is also Python object. Extend all the items of the list 2 added into the list 1. See, here it is not list. All elements of the list is added into the list 1. Those are individual elements. Got it? The difference between append and extend. Append, the list is added. Extend, items of the list is taken and added the items. Reverse, it reverses the list object. Index, search for the given value. Yesterday we discussed in the strings, find method and index method are same. R find method and R index method are same. On the list, this find method is not there. Index method is useful for searching. Got it? String slicing, I told you, same like that. List slicing, same way. Tuple slicing, same way. Tuple slicing. Okay, sort method is used to arrange in sorting order. By default, ascending order. If you give a reverse is equal to true, descending order. Sort method, original list is get modified. Original list is get modified. because this sort and these things reverse sort, these all are not possible on the tuple because tuple is immutable. You can't modify the tuple. That's why these operations are not possible on the tuple. This is unpacking the list. How many values are there in the list? 4 values are there in the list, assigning to 4 variables. So individual value assigned to individual variable, right? This is unpacking the list. Similarly, unpacking the tuple also possible. Got it? This is all examples of the list. Similarly, you see tuple, how to create the tuple, you know, this is tuple is the type. So this is a tuples of indexing, positive index, negative index. Okay, while loop, iterating the using while loop, iterating using a for loop tuple. So this is not allowed because tuple is immutable. As adding the elements, changing the elements, changing the content is not allowed. Len function is okay. Index is not available, it gives the error, index out of range error. Now you see tuple slicing, same. List slicing, tuple slicing, string slicing, everywhere it is the logic is the same. Unpacking the tuple, yes, you can unpack 4 different values assigned to 4 different variables. Unpacking the tuple. Now you observe this. Observe this. What is this? Employee details. It's like a table or not? This is originally list of tuples. List of tuples. It can be list of lists, list of tuples, or tuple of tuples. It can be anything. But 0th index days, employee number, employee name, salary, age, something like that, right? See, I'm iterating the employees list one by one tuple I'm getting. That means one by one record I'm accessing, right? One by one record I'm accessing. Yes, you can do like this. So you can arrange this data in a sorting order, sorted function. Just now I shown you list.sort method, but now this is not method. This is function. Passing parameter is the list object or a tuple object, whatever it is. But it is not modifying the original list. It returns the new list, the sorted object. Got it? If you give reverse order, in the reverse order, but you see this is not collection of values, this is collection of tuples. See the structure. So now it is based on first sort criteria, second sort criteria, etc. You see reverse order 1 2 3 9, it's okay, fine. 1 2 3 8, again 1 2 3 8, again 1 2 3 8, duplicated or not? So this time it takes combination of 2, 0th index and 1 index. Still combination is also duplicated or not? This time it extended for the next one, 0 1 2 3 combination. Based on that, it will be arranged in sorting order. Next you see 1 2 3 7, no duplicate. 1 2 3 6, no duplicate. 1 2 3 5, 1 2 3 5, duplicated or not? So 1 index, 2 index, still combination is duplicated or not? So based on the age, this is the default sorting order. Got it? That is sorted function. Sorted function. This returns a new list object. Understand? No, sir, I want to sort based on salary only. I want to sort based on salary only. In that time, you have to specify the key. Key must be a lambda expression. Key must be a lambda expression, right? So key lambda, one index. One index in the sense name, right? I will tell you what how to write the lambda expression. So it is arranged based on name or not. Sorting order is based on name or not. 2, salary, right? The descending order based on the salary or not. Like this. This is the lambda expression. You must specify key. Key should be a lambda expression. Like this you can use max. I'm specifying lambda. Max finds highest value. Max of 2. 2 is the salary. Highest salary holder details. Max function. Okay, min function, lowest salary holder details. Because here I specified key lambda expression, 2 index is salary, lowest salary holder. Like this, using lambda expression I can specify them. Understand? Then how to write the lambda expression? What is the syntax of the lambda expression? What is lambda? The syntax of the lambda expression is lambda keyword, all small letters, lambda keyword, space followed by space, followed by arguments, parameters you want, a comma b comma c comma d comma e. How many parameters you want? Either single or multiple or nothing, anything. What are the parameters you require? You can specify. Colon. Before colon is lambda keyword and arguments. Before colon is lambda keyword and arguments. So here, right side after colon, expression, something like a plus b plus c multiply with e to the power of d, something like this, right? This is my calculation, my expression, my formula, whatever I want to do, I do. Right side is the expression, left side is the specification. This returns a function object. This returns a function object. Clear? So generally I do write something like f is equal to lambda. Then what is f? F is a function. Of course, you can give ASDF. What is ASDF? ASDF is a function. Then later you can call it as something R is equal to ASDF of 4, 5, 7, 8, 9. So 4, 5, 7, 8, 9. Like this, you are calling the function, lambda function. What happens in this case? Parameters are sent. 4 goes to A, 5 goes to B, 7 goes to C, 8 goes to D, 9 goes to E. Accordingly, this calculation is done. It returns that. Output goes to R. So lambda is nothing but a lambda expression is nothing but a function definition. You are calling the function. This is an unnamed function, lambda function. It is none other than function object only. It is none other than function object only. Just you observe practically. Let us see this quickly. See what I am doing. Lambda x comma y comma z, x plus y multiply with z. I assign to f. F is going to be the function. I am calling the function 3 comma 5 7. 3 plus 5. 3 plus 5, 8. 8 multiply with the 7. The result. You observe. See function lambda. What is f? It is a function. What type of object it is? It is class function. It is an object in Python. So it is the ID. Then what is the result here? 56 is the result. I am calling the function or not, passing the parameters or not, getting the return or not. This is lambda. How to write a lambda? Now you see here I gave L1. This is the list L1. So lambda, single parameter. Parameter can be any Python object. That is a list object. L1 is the list. 3 index. 0, 1, 2, 3, 45. Output will be the 45, right? Because X is pointing the L1 list. Understand? Suppose if I give T1 tuple. Now X is representing tuple T1. So 3 index item 25, right? Clear? Now you observe this example. E1, key of E1 greater than key of E2. What is this? 2 index item. E1 is the list tuple, E2 is the tuple. Here it is 53,000, here it is 40,000. 53,000 is greater than 40,000. Gives the result to true. This is how you can use lambda expression. The same thing I am doing here. Lambda of X. X is going to be employees. X of 2 indexed item. That is considered as a key, right? That is considered as a key. So based on that, it is arranged in the sorting order. So this is the syntax. It should be lambda expression. Understand? Similarly, max and min. You can specify lambda expression key as a lambda expression. Then you can work based on particular thing. This is all about tuple, right? List and tuple. You understand? List and tuple, you understand? Similarly, set, you see.
The lambda function, what is X?
Creating all items in the set, different sets.
Hello, sir.
How to create set.
Hello.
Set is iterable, so you can iterate the set using for loop. Add method is used to add a new item to the set. Where it will be added? Danishtam. Its own location. You can't decide the location, right? Just add the item into the set. Where it will keep, let it keep it. Okay. Add a new item to the set. That is the add method. Remove method. Remove the specified item. Remove the given value because there is no index. So remove method gives the error, returns the key error if the item not found. So we have another method, that is discard method. Remove method and discard method both are same, is used to remove an item from the set, but discard method does not give any error. Shouldn't it? Discard method doesn't give any error. 6 is not available, so nothing is deleted, but still no error. But remove method, same thing, but it gives the error. 6 is not available, key error. If you want the system to give the error, use the remove method. If you don't want system to give the error, use the discard method. Okay, double అడిగినప్పుడు తిట్లు తినాలంటేనేమో నన్ను అడగండి, తిట్లు తినొద్దు అనుకుంటే అమ్మని అడగండి. Okay. Right, pop method. Here there is no index. Specifying the index is not possible. Pop method deletes an item, return the deleted item. It always deletes the first item in the set because set does not support index. It is internally organized by the arbitrary index generated by the hash function. So 32 is deleted, then 4 is deleted, then 5 is deleted. Always it deletes the first located item of the set. It returns the deleted value. Pop method, similar behavior. Then update method, set 1 is updated with the set 2. These all, of course, set operations also there that we continue tomorrow. Okay, tomorrow sets and dictionaries we discuss. Tomorrow we have a long session, same time, 7:30, 7 o'clock we'll start. Tomorrow 7 o'clock we'll start, and tomorrow I have to complete these data structures and also complete functions. Functions chapter, functions also I will complete. Okay, so tomorrow we'll complete the functions and we'll wind up. For the functions 2 hours are required. For the data structures 1 more hour is required. Tomorrow approximately 7 to 8, 8 to 9, 9 to 10 at 10:30. Okay, 10:30 Linux class. Okay, yeah, okay, fine. So tomorrow at 7 o'clock.
Sir, can you share this example in Google Drive?
Thank
Hello.
you. See you tomorrow.
Hello. Hello, sir.
Otherwise, I
Hello.
will